Hello, we're going to look over a few financial matters and indice problems involving exponents. So we're going to look at example 7, and it says, when the first Android phone was launched, it sold for $600. 6 months later, the price was $360. Use the laws of indices to calculate the average percentage depreciation per month. Now, they're using indices is the same thing as exponents. I'm American, so I use exponents. British, they use indices. So I hope that I don't know if I didn't clarify that in the last few videos, but indices, exponents are the same thing. So, well, we know that when the Android, it was $600 to begin with, and then 6 months later, it was $3,600, right? So I know that I had to take $600, right? And then it's going to depreciate, but I'm just going to write it like this. I know it has to be 1 plus some type of ratio R, and then after this rate right here, after 6 months, it depreciated to 3,600. Good. And then if I take 3,600, not 3,600, 360 and divide it by 600, I'm going to be left with 0.6, I think it is. I'll just check real quick. Over 600 comes out to 0.6. And then I could solve this problem by raising both sides to the 1/6 power. If I raise both sides to the 1/6, that's a 6, that becomes 1, that's 1/6, and I get 1 plus R. And if I do 1/6, 0.6 to a 1/6 power, comes out to something roughly around 0.9183385, whatever, and so on. And then if I subtract by 1, I'm going to end up with a negative 0.08161. So here you can see the depreciation. It's going to go down by, if we write this as a percentage, we can round up by 8.2%. 8.2%. If you did it the way the book would, you could have know it was depreciating, so you could have wrote this as a minus, and it just, this number would have come out positive and so on. But I know it's depreciating when you get the negative, so as long as you understand whether it's depreciating, it could be appreciating, meaning it's gaining. Maybe something goes up, but this situation, you know, as the Android, as time went on, the Android price kept going down, right? It's going to go down, not up, right, as it got older, and so on. So what we just seen right here is an example of what we call simple interest, right? And here's the formula for simple interest. If you have the amount that you have, usually is represented by A. The book has a little bit different variables that they use, but I'm going to use these. P stands for principal. Principal is don't get that confused with like the principal of the school, but a principal of an investment or an amount. Think of it as a starting amount, or a lot of time you'll hear it initial amount is something we use a lot. And then rate, the interest rate, or APR stands for annual percentage rate, and T is the time that we allotted. In the last problem we saw, the first problem we saw was the time was 6 months, right? But the time could be years, minutes, seconds, whatever. So now we want to go over something that is called compound interest, right? So compound interest is something that happens like this. Let's say I invest $100, right, at a interest rate of, we'll say, let's just say 5%, right? Now I can compound it differently in different intervals. If it's simple interest, I'm just going to apply the interest at the end of each year. But sometimes you can end up compounding it. The total year is 5%. This is also our APR. But I could compound it, like, let's say every twice a year, or we could say semi-annually, right? What would end up happening? So that means I get 5% for the year, so my amount would be 100, but 5% for the year. But if I'm going to end up halving that percent, right? Because in 6 months' time, I'm going to compound the interest. So what I have to do is take that plus 0.05 and half it, right? But if I go, let's say we do it for 10 years, then I'd still 10 years, if I'm every 6 months, I end up doing it 20. So I'd take 2 times the 10, because there's 20 times that this is going to be evaluated. So that's compounded half a year. What if I wanted to do it every quarter? So 4 times a year. So this would be compounded quarterly, and it'd be 1 plus 0.05 times 4, and then 4 times 10. Because if I do it every 3 months in 10 years, 10 times 40, this interest is going to be applied 40 times. And then I can do monthly, and I'd go 100, 1 plus 0.05. There's 12 months in a year, and then 12 times 10. And even daily, I can go daily, and I'd go A is equal to 100, 1 plus 0.05, 365, 365 times 10. This is what compound interest. We're still getting 5% for the year, but depending if this one here is, we could say this is semi-annually right here, and then this is, we're going to go quarterly. So this is half a year. This is a quarter of a year. This is, we found this monthly, and this is daily, every day, so, and so on. So, and that's what that is. So the formula for compound interest is the following formula, right? And compound interest, we still have the amount, and the principal, your initial amount, is right there. 1 plus the rate divided by the number of times that the amount is compounded, and then you take the number of compoundings times the t, so that's what compound interest is. The book didn't really, there was an investigation, but you might have seen this in your previous algebra classes, but I thought it was good to point out because it will help you with some of your homework assignments.